Welcome viewers, welcome to the new lesson from Dr. Arts Biology. If you did not subscribe the channel, you can just click on the subscribe button and bell icon. Welcome students, hope you are following the topic well and make sure that you are learning one by one, step by step to avoid confusion later. Okay, in this particular lesson, we are going to deal with the structure and importance of NAD+. Okay, so we will now see why it is NAD+, and why we are just writing NAD, H+. All those questions will be finding answers in this particular lesson. Okay, so let us see. NAD, what is its full form? Niacinamide or nicotinamide. I'm just writing niacinamide. Adenine. Dinucleotide. So two nucleotides are linked. First nucleotide is the niacinamide and second one is the adenosine. So niacinamide, adenosine or adenine dinucleotide is actually the NAD+. It is otherwise known as nicotinamide also. Okay. Now what is actually this niacinamide? We know the niacin. Okay. So niacin structure is the vitamin. Okay. Hope you remember that. So niacin is nothing but the one which is looking like this. There will be a nitrogen in the lower part. So the nitrogen will be there in the lower part. So this is hydrogen. We can just fill the valency. 1, 2, 3, 4. Now again hydrogen here. 1, 2, 3. Double bond here. So nitrogen valency is filled. H. 1, 2. So this part is this particular thing will be having a particular structure where this carbon is having double bond with oxygen and then actually a hydrogen will be here. The niacinamide, to replace that particular hydrogen, the niacinamide will be having an amino group at this particular point. So this is niacin. So you can just note down this as the niacin. Just redraw one more figure where this hydrogen is just replaced by the amide. Now it becomes niacinamide. Okay, niacinamide. Now let us see the structure of niacinamide or nicotinamide adenine dinucleotide. Okay, so I am just drawing the dinucleotide structure here. So we just need one sugar molecule here, HOH, HOH, HCH2, then beta ribose sugar, therefore H, and this one will be linked with the nitrogen of adenine. And we can see that in this way, nitrogen again, and it will be linked, nitrogen, and we know that adenine contains amino group on top, and therefore NH2, double bond, then here hydrogen, again 1, 2, 3, double bond here, and double bond here, H. Okay, so that is the adenosine nucleoside. Now, this one is linked with the phosphate group. Okay, I'm just linking phosphate with blue. So, O, then phosphate, again O, and then again phosphate of the next nucleotide. Which is the next nucleotide? The niacinamide. Okay, so again, one more phosphate group, again one oxygen. So you have a double bond O here, double bond O here. O minus here, O minus here. 2-phosphate group is there. Now let us see the niacinamide. There also what we need? We need a sugar molecule. Where CH2, then H, then O, the same ribose sugar, H, OH, H, OH. Okay, the same ribose sugar. Now beta ribose H. Then it is linked with this particular nitrogen. We can see the change then. This particular nitrogen, when it is linking with that hydrogen, it will be gaining a positive charge because it will be having that particular what? Extra bonding. We know that the valency, original valency is 3 and it will be changing into 4. Hope you got it. Okay, so that will be happening here. So N positive charge will be happening and that positive is actually coming here as a NAD plus. And the remaining portion is exactly same as what we have drawn there. So entire thing, entire molecule is same structure. Okay, so this part C, double bond O, amide, then hydrogen here, hydrogen here, hydrogen here, and then hydrogen here. Okay, so double bonding possibility whatever. So this is actually the NAD plus. Now we have to change that NAD plus into NADH plus H plus. So I am just taking the entire this part as the R. Okay, so R is actually, I am drawing a figure here and the R here is actually representing the entire thing that is coming in this way. Okay, so this entire part will be R. So I am just taking this figure again here. Okay, so we can see that I am just drawing it here. So this is a niacinamide. Don't forget that. This is amide derivative of the niacin. So I'm just changing, I'm just forwarding the reduction process that is happening to the NAD plus. I'm drawing only that particular niacin portion. Okay, niacinamide portion. So I'm just redrawing this particular figure. Okay, H, C, double bond O, NH2. Okay, so when this molecule is undergoing reduction, 2H plus is added, 2E minus is added. When it is undergoing reduction, where is the site of addition of H plus and the electrons? We can see that for electrons, 2 places there. But for hydrogen, proton, only 1 place is left because the 1 place is already utilized by this particular nitrogen. You can see the positive charge already there. So there is no chance for addition of 1 more hydrogen. As a result, this hydrogen will be staying out, but 2 electrons will be accepted. So we can see that the hydrogen will be added at this point. Okay, so this H plus will be there. So we can see the H plus will be looking like this. So this H plus is added here, 1 H plus is added here, and 1 electron also will be added at this point. The second electron will be accepted by this particular nitrogen. Okay, I'm just drawing R, which is actually representing the entire structure. So what is left there? Out of the 2 H plus, only 1 is incorporated into the molecule and the remaining 1 H plus is there out. So that's why we are just writing as NADH plus H plus. This is the reason why we are writing like this. The proton is not added to the molecule. Instead, the electrons are added and 1 proton is staying outside. It will be always staying outside. So this is a bit nearby that. And that's why H plus is out. Now let us fill the valency. 4 valency is filled. Now here 1 valency is required. Okay, and one will be accepted. A lone pair of electron will be retained there, because we know that in this case the fourth valence is filled. We know that the fourth valence is formed by the lone pair of electrons. Now there is no 4 valency, only 3 valency is there. As a result, this lone pair of electron will be staying out as this particular thing. That's why I put that particular dot. Okay, don't forget to do that. So that's about NADH plus H plus. Okay, ensure that you are learning this particular structure of niacinamide adenine dinucleotide in this way. It is actually 2 nucleotide linked, okay, through a phosphorus 1 hydrate only. Phosphorus 1 hydrate, and this one is phosphoester, and this is also phosphoester. In case of DNA only, we can see the phosphodiester bond. Okay, so 2 nucleotides are linked. One nucleotide is adenine nucleotide and second nucleotide is niacinamide nucleotide. Niacinamide is nothing but the amide derivative of niacin. In niacin, here you can find hydrogen. Here you can find, in niacinamide you can find amino group, and that is linked. The site of addition of electron and hydrogen are nothing but this particular carbon and this nitrogen. And as a result, 2 electron will be added, 2 proton will not be added, only 1 proton will be added. And that is why we are just writing as the NADH plus H plus. As both the NAD plus and NADP will be working in the same pattern, or it is actually higher energy containing molecules than FMN and FAD, we can just discuss the importance of both NAD plus and NADP together. So for the purpose, we have already learned about the structure of NAD plus and its reduced state NADH plus H plus. In the same way, we also have to learn about the NADP before learning its importance. Okay, so let us see the structure of NADP. From the name itself, we can see that it is almost same as NAD except the P. And we know the P stands for the phosphate. So phosphate is added to the NAD plus molecule, then it will be forming the NADP. Now the question is, where this phosphate group is added? Actually, the phosphate group is added to the niacinamide nucleotide. In that, we know that ribose sugar is there, and in the ribose sugar, the second carbon will be having a phosphate extra. So that's why it is known as the NADP, niacinamide adenine dinucleotide phosphate. I'm not writing the full form here because we already learned about the name niacinamide adenine dinucleotide. Only the phosphate is coming extra. Okay, so let us see the structure. Hope you remember the structure of NAD plus. So what you have to do is pause the video and try to draw the structure of NAD plus as you are on. Okay, and after that, then resume the video so that you can just compare with the diagram, the structure that I have drawn here and the one that you have already done. Okay, that is a way to learn the structures perfectly, and you have to try, and only if you are trying you will be getting that particular touch. Okay, so let us see so before that you have to pause the video. Now I am just going to draw the structure. Okay, so we know that it is 2 nucleotide. It contains 2 nucleotides. That's why it is known as dinucleotide. So the first one is nothing but the adenine. So you can see the adenine. So first of all, we have one sugar molecule, that is ribose. Okay, and ribose is in beta position, and this ribose is linked with the adenine nucleotide. So I am just drawing the adenine here, and then there is the second ring of the nitrogen base, and here adenine, we can see the amino group is here. Okay, and we know this is a double bond, so here we can see the nitrogen. After that you can find hydrogen here and a double bond here, one more double bond here, double bond here, and H here. So this is the structure of adenine. Okay, now we can complete the sugar molecule HOH, and then HCH2. We have to link with the oxygen, then phosphate, again oxygen, again phosphate, and again oxygen. Okay, so this is the bridge between the two nucleotides, and now this particular thing is linked with the CH2, which is the part of which is connected with the fourth carbon of ribose. I'm just drawing ribose again. Okay, and the first carbon of ribose in beta position will be having connection with the niacin. Okay, the nitrogen containing molecule. So you will be having niacin here. So nitrogen. Okay, so hydrogen is present here, hydrogen here, hydrogen here, again hydrogen here, and one C which is having double bonded O and NH2. So let us see the valency. Then there will be a positive charge, this one. Okay, so this actually form the niacinamide adenine dinucleotide. Okay, now where is actually this phosphate comes? This phosphate is actually coming at this second carbon position. So OH is there. Instead, you can find O, P, double bond O, O minus, O minus. Okay, so we have to add the remaining part of the phosphate group, O minus, O minus. This is actually the structure of NADP. What is extra than NAD? Only this particular phosphate group that is added to the second carbon of ribose sugar of niacinamide nucleotide. There is no other difference. The other thing is exactly same. There is no other difference. So that is what actually mean by the NADP and its structure. Now we know that the NADPH will be there. The same thing will be happening. Hydrogen will be added at this point, and the electrons will be added at this and this point, and one H plus will be out. So NADP and NAD structure is now familiar to you. Just try to draw it once more without looking. Okay, so you can just watch the video 1 or 2 times, and after that you just try to draw it. If you are just simply leaving it there, you will not be learning the structure. You can easily draw this particular structure, there is no issue. First, just make your brain to do that. Okay, plan yourself. NAD, what is there? Niacinamide is there, adenine is there. It's a 2 nucleotide. So you have to draw adenine nucleotide and niacinamide nucleotide. So in that way, you have to plan your brain to draw that particular thing and identify where is the mistake simply by looking into it and whether the valence is full or not. Then you can easily draw that particular structure. There is no issue in that. You don't worry about any structure. So this is a way how can you draw the structure easily. So that's about NADP. Now what we can see is, let us see the importance of NAD plus and NADP together. Okay. So I am not drawing the reduced state because we already have the reduced state and only this part will be changing. The remaining entire thing will be coming as the R. And this part changing is similar to the NAD plus. So I am not redrawing the same thing here. You can just move back to the first part of this particular lesson. Then you will understand what is happening during the reduction process. Okay. So let us see the importance of NAD plus and NADP. As I told you, the importance of NAD plus and the NADP is almost same. Only they differ in their enzyme specificity. Some of the enzymes will be specific to NADP and some others will be specific to NAD plus. You can see the NAD plus in most of the carbohydrate metabolism and all, and you can see the NADP in fatty acid metabolism and all. Okay, so let us see what will be happening here. So what is the role played by the NAD plus and NADP? So both are acting as coenzyme. Coenzyme. We know that an enzyme is composed of apoenzyme and cofactor. Okay, and altogether it becomes holoenzyme, functional enzyme. And there are three types of cofactor: prosthetic group, coenzyme, and metallic ions. So there are mainly three types of cofactor. When any one of these cofactor will bind to the apoenzyme, that is a protein part of the enzyme, it becomes a functional enzyme. So that is a normal thing that you have already learned in grade 12, but still I am just saying it for your rewinding that particular thing. Okay, so coenzyme is one of the cofactor which is actually activating the enzyme. Now here you can see that NAD plus and NADP will be acting as a coenzyme. Okay, for what kind of enzyme? Coenzyme for dehydrogenase. In the enzyme classification, we have learned about the oxidoreductase enzyme. It is otherwise known as the dehydrogenase enzyme, where both the reduction and oxidation is happening in a chemical reaction. So it acts as a coenzyme for dehydrogenase in redox reactions. Okay, so that is the first role played by the first importance of NAD plus and NADP. So in continuation of this, we can see the second importance. What? It acts as the electron donor. It will be acting as the electron donor when it is in reduced state. So it gives off electron when it is in reduced state. And what are the reduced state of NAD plus and NADP? And we know that it is nothing but NAD H plus and NADPH. So when it is in reduced state, it will be acting as the electron donor. And also it acts as the electron acceptor when it is in oxidized state. And oxidized state, we know that it is nothing but NAD plus and NADP. Okay, so that is how this particular molecule is functioning in continuation with the first role. So it will be acting as, whenever an electron donation is required for continuing a chemical reaction, this particular molecule will be actually supporting that. Whenever it is not required, it will not be. Okay, whenever it require it acceptance of electron, it will be just accepting it. When And at that time, NAD plus and NADP will be playing a role. Okay. Hope you understood what it is. Now, we can see the third importance. Third importance is also in the form of electron donor and acceptor. So it will be acting as a source of electron. Okay, it will be acting as a source of electron. In what kind of reaction? In addition to these redox reactions, it will be acting as a source of electron for hydroxylation. We know what is meant by hydroxylation, the hydroxyl group adding, and desaturation. Hydroxylation and desaturation. What is desaturation? It is nothing but addition of double bond. It is what we mean by the desaturation. So it acts as the electron donor or electron, the source of electron for hydroxylation and desaturation of what kind of molecule? Aromatic and aliphatic compounds. These are the three importance of NAD plus and NADP. So first of all, it acts as a coenzyme for dehydrogenase enzyme, where that is catalyzing the redox reaction. Second thing, it acts as the electron donor when it is in reduced state, and it acts as the electron group acceptor when it is in oxidized state. And then third importance is it acts as a source of electron for hydroxylation and desaturation of aromatic and aliphatic compounds or molecules. So that's about the importance of NAD plus and NADP. Hope you understood the concept. Make sure that you are learning in the proper way by revising, and make sure you have learned it before you step into the next topic. So we will be just discussing the next one, FMN and FAD together, because that also is similar. FMN mononucleotide only. When adenine is added, it becomes FAD. The functioning will be the same, and the role played also will be same, except the specificity for different enzymes. That will be varying. Okay, so we will be seeing the importance of that particular molecules in the next lesson. Before that, when you are getting a question, explain the structure of NAD plus, explain the structure of NADP, etc. What you have to do? You have to draw the structure, and if you are just leaving by drawing the structure, you will not be getting the full mark. Now, how can you explain it? Just say the individual components of that particular molecule, because we can explain it in this way. NAD plus, it is composed of niacinamide nucleotide and the adenine nucleotide together linked with the phosphoester bond. Okay, and niacinamide nucleotide is actually a derivative of vitamin niacin, and this adenine is there in the adenine nucleotide. That way you have to explain. And what are the linkage between nitrogen base and sugar? What is the linkage between the sugar and phosphate? In that way you have to explain it, then only it becomes the complete answer. Okay, so hope you understood how to answer that particular question. So let us see the next part, that is FMN and FAD. Thank you.